Hey guys, Pixtrick here. Recently I made a video about custom shadows in Unity and someone asked me to make a tutorial out of it. Just so you know, I would consider that you know the Unity basics, otherwise I would recommend checking out the Breakis channel, for example, to get used to Unity in general. So, here's how to make custom shadows in Unity URP using shader graph. The first step is to check that your project is configured with URP or HDRP. If not, I leave you a link in the description for that. Next, you have to create your shader graph by right-clicking, create shader graph URP, unlit shader graph or lit shader graph. You can pick either unlit or lit shader graph, depends on what kind of style you want. I'll go for a cartoonish style with the unlit shader graph, but it's just what I prefer. Then create the material from the shader, right click on the shader graph, create material, then apply the material to your mesh and go in your shader graph, double click on the shader graph. The following part will help you create a basic toon shader on which we will implement our custom shadows. You can skip it and just copy the files if you're not interested in the explanations. All the links in description. Okay, so you're in the shader graph. You have to implement different things. The first one is a custom function that will get some information on the main light of the scene. Just copy the .hlsl file that I put in the description and put it into your folder. This file contains the custom function that we need to retrieve the main light information, such as the direction, the color, and the world position of the light. I won't explain how it works since it's far beyond the scope of this video, but if you're interested, I try to leave a link in the description. Now that you successfully copied the custom lighting file, you can add a custom function node into your shader graph and select in the graph inspector the .hlsl file you just copied before. Then enter one vector3 input you will name world pose, and 4 outputs: a vector3 named direction, a vector3 named color, a float named distance atten, and a float named shadow atten. Also make sure you use the main light function by typing main light in the name input, otherwise it won't work. Now link the input to a new position node. Make sure the space is set to absolute world. We'll now determine how the light should react to the mesh. First, we have to create a normal vector node, which returns the normals of the mesh. Then we normalize it and compute a dot product between the resulting vector and the light direction vector. This dot product represents how much light a face should receive. Basically, it goes from -1 to 1, and the more the value is close to 1, the more the face captures the light. Now we will determine the intensity of shading of the mesh. Create a smooth step node and link the out to the inner slot of a new step node. Link the edge slot of the step node to a float and convert it to a property that you will name, for example, shadow step. Link the out slot of the step node to a new multiply node and link the remaining inner slot to the shadow atten output of your custom function. Link the output of the multiply node to a new multiply node and link the remaining inner slot to the color output of your custom function. Then multiply the result by a color and convert it to a property that you will name, for example, main color, which is the main color of your mesh, which is white in most cases. What that part does is basically creating a uniform shadow and a uniform lit color. By the way, you can adjust the shadow step property to increase or decrease the proportion of shadow on the mesh. Okay, so now our toon shader is done. We just have to make the custom shadows. Link the output of the multiply node to a 1- node, then a clamp node. Make sure the clamp node minimum is 0 and the maximum is 1. What that part does is selecting only the shadow, kind of. Elsewhere, create a texture 2D node and convert it to a property that you will name, for example, shadow texture 2D. Link it to a new sample texture 2D node. Link the UV input to a new tiling and offset node, and link the tiling input of that node to a vector2 node and convert it to a property that we will name, for example, shadow texture tiling. The tiling and offset node is used to change the pattern size of the shadow. Note that you can put a float node instead of a vector2 node. You won't have the control of horizontal and vertical sizes of the texture, but in most cases it's a simpler approach. Now take the output of the sample texture 2D node and link it to a new multiply node. Link the remaining inner slot to a new color and convert it to a property that you will name, for example, shadow color. Make sure you make this color an HDR color. Take the output of the sample texture 2D node again and link it to a new 1- node. Link the output to a new multiply node. Link the remaining inner slot of that node to a new color and convert it to a property that you will name, for example, shadow pattern color. Make sure you make this color an HDR color. Now create a new add node and link the two multiply nodes outputs to the add node inputs. Take the output of this node and link it to a new multiply node and link the remaining inner slot to the clamp node output that we made previously. Let me explain quickly what we do here. We take the pattern texture and apply a color to the black, which is the pattern, and the white, the shadow, separately. Then we add them together and multiply the result by the shadow selected, so that only the shadow is affected by the pattern. Now we just have to add the custom shadow to our toon shader. So for that you have to create a new add node and link the two multiply node outputs to the add node inputs. Take the output of this node and link it to a new multiply node. Link the remaining inner slot to a new sample texture 2D node and link the texture 2D input to a new texture 2D, the property one, and finally convert it to a property that you will name, for example, main texture. Finally, link the multiply node output to the base color input of the vertex fragment, and that's all. Enjoy your custom shadow. Before you go, just a quick tip to make decent patterns. If you want to create dot-like patterns, such as dot, obviously, hearts or stars, for example, just try to put your pattern at the very center of the image. If you want to create continuous patterns, such as lines, dotted lines, wave, etc., you will have to make sure the patterns can repeat, which means that they have to end on the same height or width. And that's all for the custom shadows in Unity. I hope you enjoyed the video and I'll see you next time.